The rate at which electric energy is consumed in an electric circuit is called its power. For an AC circuit, we define instantaneous power as the product of instantaneous voltage and instantaneous current. Uh, Suppose in an AC circuit, so power is defined as the product of instantaneous voltage and instantaneous current. Suppose in an AC circuit, the voltage and current at any instant are given by E is equal to E naught sine omega t. Suppose in an AC circuit, the voltage and current at any instant are given by E is equal to E naught sine omega t, and E is equal to E naught sine omega t, and I is equal to I naught sine omega t minus phi. Phi is the phase difference between EMF and current. So E is equal to E naught sine omega t and I is equal to I naught sine omega t minus phi, where phi is the phase angle by which the voltage E leads the current I. The instantaneous power is given by, so instantaneous power is given by P is equal to EI. P is equal to EI. What is E? E is E naught sine omega t, and what is I? I is equal to I naught sine omega t minus phi. So P is equal to E naught I naught sine omega t into sine omega t minus phi. I have taken this E naught at first place and I naught at second place. E naught I naught sine omega t multiplied by sine omega t minus phi. Now we have one formula. We have four set of formulae in trigonometry. 2 sine A cos B. It is sine A plus B plus sine A minus B. 2 cos A sine B sine A plus B minus sine A minus B. 2 cos A cos B, it is cos A plus B plus cos A minus B, and 2 sin A sin B, it is cos A minus B minus cos A plus B. You might have learned these formulae in mathematics. So 2 sin A sin B, I am going to use this formula here. This is the set of four formulae of trigonometry, wherein we multiply sine, cos, cos, sine, cos, cos, sine, sine. So these are the set of these four formulae which we use in mathematics. So 2 sin A sin B is cos A minus B minus cos A plus B. So I have sine multiplied by sine. It means I can make use of this formula, last one, 2 sin A sin B. I will multiply it by 2 and divide it by 2. P is equal to E naught I naught upon 2 E naught I naught divided by 2 and sin omega t minus phi multiplied by 2. 2 sin omega t into sin omega t minus phi. So 2 sin A sin B is equal to omega t minus phi cos A minus B minus cos A plus B omega t plus omega t minus phi. P is equal to E naught I naught upon 2 into cos omega t plus phi minus cos 2 omega t minus phi. Omega t minus omega t cancel out. P is equal to E naught I naught by 2 cos phi minus cos 2 omega t minus phi. Okay, so average power dissipated per cycle is this clear to you till now?
Yes,
Average power dissipated per cycle is equal to average power dissipated per cycle is equal to average of average of E naught I naught upon 2 multiplied by cos phi minus cos 2 omega t minus phi. Cos phi minus cos 2 omega t minus phi. Now I am onto the last line of page number 27. The second cosine term cos 2 omega t minus phi is time dependent. Is time dependent because it depends on time. So its average over a cycle is 0. Anything which depends over time. So over one complete cycle, I know that the value of sine omega t is also 0 and the value of cos omega t will also be 0. So because this second term cos 2 omega t minus phi, it is time dependent, so its average value over one complete cycle will be equal to 0. So I will write the second cosine term since the second cosine term cos 2 omega t minus phi is time dependent, so its average over its average over one complete cycle is 0. Its average over one complete cycle is 0. over one complete cycle is 0. Therefore, so this value will be equal to 0. This value will be equal to 0 because it is time dependent. It depends on time. E naught I naught by 2 into cos phi. So P average, therefore, P average is equal to E naught I naught upon 2 cos phi. E naught I naught upon 2 into cos phi, or P average is equal to, E naught upon root 2 multiplied by I naught upon root 2 into cos phi. Why I have divided it like this, E naught upon root 2 multiplied by I naught upon root 2? Because E naught upon root 2 is ERMS. E naught upon root 2 is ERMS. I naught upon root 2 is IRMS cos phi. ERMS, IRMS cos phi. Now, we know that cos phi is equal to R upon Z. Since cos phi is equal to R upon Z, in case of a series LCR circuit, therefore P average is equal to ERMS, IRMS into R upon Z. Into R upon Z. Special cases. Now, special cases. Is that clear to you till now? We have seen in series LCR circuit that cos phi is equal to R upon Z. Now, I am going to tell you the concept why this cos phi is called power factor of the circuit. This is called power factor of the circuit because ERMS is a fixed value, RMS value of EMF is a fixed value, IRMS is a fixed value, and this R upon Z, this cos phi, actually the basic thing is this cos phi which determines the power of this AC circuit, because ERMS is going to be the same, IRMS is going to be the same. It's cos phi which keeps on changing. Okay, so that's why this cos phi is called power factor of the circuit. Have you noted down till here? Are you listening? Anusha, are you listening?
Sir, I'm writing. 1 second.
Okay.
Okay.
Okay. Special cases, pure resistive circuit. So first special case will be this pure resistive circuit. Pure resistive circuit. In pure resistive circuit, we know that what is the value of phi in case of pure resistive circuit. In case of pure resistive circuit, this EMF and current in case of pure resistive circuit, this EMF and current, they both are in same phase with each other. That it means that there is no phi. E is equal to E naught sine omega t in case of pure resistive circuit, and I is equal to I naught sine omega t. So there is no phase difference, that is phi is equal to 0 degree in case of pure resistive circuit. Phi is equal to 0 degree in case of pure resistive circuit. Therefore, P average is equal to ERMS multiplied by IRMS, ERMS multiplied by IRMS multiplied by cos phi. And what is phi? Phi is 0 degree. Cos 0. Cos 0 is 1. Note down till here. Then I will switch on to the next slide.
Yeah, sir.
Okay. So P average is equal to ERMS into IRMS. P average is equal to ERMS multiplied by IRMS, and ERMS is equal to, I know that ERMS is equal to IRMS into R. Basically, what is this? This is voltage. What is this? This is current. Voltage is equal to current into resistance. This is Ohm's law. This is nothing but Ohm's law. So, in place of IRMS, I can write ERMS upon R. ERMS whole square upon R, or P average is equal to ERMS IRMS. So in place of ERMS, what I can write? In place of ERMS, I can also write IRMS into R. IRMS multiplied by R into IRMS is equal to IRMS square into R. So we can write it like this also. Okay. Now, second case is pure inductive circuit. Purely inductive circuit. Purely inductive circuit. In case of purely inductive circuit, we know that E is equal to E naught sine omega t. We know that E is equal to E naught sine omega t, and I is equal to I naught sine omega t minus pi by 2. Omega t minus pi by 2 in case of pure inductive circuit. So, what is the phase difference in this case? What is the phase difference? Phase difference is of phi, means pi by 2. Phase difference is of pi by 2. So, therefore, here phi is equal to pi by 2. Therefore, P average is equal to ERMS into IRMS into cos pi by 2. What is cos pi by 2? Cos pi by 2 is 0. 0 into anything is equal to 0. So P average is equal to 0. Similarly, purely resistive circuit, purely inductive, purely capacitive circuit. Purely capacitive circuit, we know that E is equal to E is equal to E naught sine omega t, and we have done it in purely capacitive circuit. And purely inductive circuit we have done it. E is equal to E naught sine omega t, and we have derived it I is equal to I naught sine omega t minus pi by 2. And in purely capacitive circuit, we have taken E is equal to E naught sine omega t, and we have derived I is equal to I naught sine omega t plus pi by 2. Omega t plus pi by 2. And what will be the value of phi? Just see that here I have taken E is equal to power in an AC circuit. Just to calculate power in an AC circuit, I have taken E is equal to E naught sine omega t, and I is equal to I naught sine omega t minus phi. Minus phi. So minus phi is there. So purely inductive circuit, I have I naught sine omega t minus pi by 2. It means that pi by 2 is equal to phi. But here it is omega t plus pi by 2. So I can also write it like this: I naught sine omega t minus pi by 2. Omega t minus pi by 2. It implies that phi is equal to minus pi by 2. Phi is equal to minus pi by 2. Therefore, P average is equal to ERMS into IRMS, ERMS into IRMS into cos minus pi by 2. Cos minus pi by 2. And we have that cos has a special property that cos minus theta, minus sign gets consumed inside. Cos minus theta is equal to cos theta only. So ERMS into IRMS cos pi by 2. What is cos pi by 2? It is 0. So in this case also average power will be 0. So average power will be 0 in purely inductive circuit, average power will be 0 in purely capacitive circuit. Now next, series LCR circuit. Fourth special case is series LCR circuit. Series LCR circuit. For a series LCR circuit, P average is equal to ERMS into IRMS into cos phi. ERMS into IRMS into cos phi, where phi is equal to tan inverse XL minus XE upon R. Tan inverse XL minus XE upon R. Fifth special case is power dissipated at resonance in LCR circuit. Power dissipated at resonance in series LCR circuit. Dissipated at resonance in series LCR circuit. So in the case of resonance, at resonance, XL is equal to XC and Z is equal to under root R square plus XL minus XC's whole square. And when XL is equal to XC, XL is equal to XC means XL minus XC will be equal to 0. So what will be the square of 0? It will be 0. So only under root R square will be left. That is Z is equal to R. So cos phi is equal to R upon Z, and R and Z are equal. So it is equal to 1. Cos phi is equal to 1. So P average is equal to, therefore P average is equal to ERMS into IRMS. ERMS into IRMS. Now, the next topic is power factor. You note down till here. Note down till here.
Yes, sir.
Okay.
I'm done.
Sorry? Okay, okay. Now the next topic is power factor. Average power of an AC circuit is given by of an AC circuit is given by P average is equal to ERMS into IRMS into cos phi. So average power is equal to, we also call this one, we also call this ERMS, we also call it virtual EMF, and we also call this IRMS at virtual current. So P average, average power is equal to average power is equal to virtual EMF into virtual current virtual EMF into virtual current virtual EMF into virtual current into cos phi. The product ERMS dot IRMS does not give the actual power and is called apparent power. ERMS dot IRMS do not give us actual power. It is apparent power. It gives actual or true power only when multiplied by the factor cos phi. The factor cos phi is called power factor of an AC circuit, and this average power is called true power. This is called true power, and ERMS dot IRMS, this is called apparent power, and this cos phi is called power factor. So P average, in place of P average we can write true power, and ERMS dot IRMS, this is apparent power, apparent power, and this cos phi is power factor. This is power factor. Okay, the true power is equal to apparent power into power factor. Thus, power factor may be defined as the ratio of true power to the apparent power of an AC circuit. Power factor is also defined as true power divided by apparent power. Please note down this relation also, because every time the value of R and Z are not given. Sometimes they give us the value of true power and apparent power, so we can calculate this power factor R upon Z. Now the next topic is wattless current. Give me 2 minutes, I will be right back in 2 minutes. Okay, now next topic is wattless current. Please mark it, it is very important. Wattless current. As a teacher, I believe that every topic is important. You might be thinking that I am saying every every topic I call it important one. Then is there anything to leave? Wattless current. Wattless current. Wattless current means current which does not contribute to any watt. Watt means watt is the unit of power. Current which does not contribute to any power is called wattless current. Okay, the current in an AC circuit is said to be wattless if the average power consumed in the circuit is zero. The current in any circuit is said to be wattless. Current in any circuit is said to be wattless if the average power consumed in the circuit, if the average power consumed in the circuit is zero. If average power is zero, then that current is called wattless current. The average power is given by average power is P average is equal to ERMS into IRMS into cos phi. ERMS into IRMS into cos phi. Now on to page number 30. Figure shows the phase angle between phi ERMS and IRMS. The current IRMS can be resolved into two components. Okay. So look, P average is equal to ERMS into IRMS cos phi. Now I will show the angle between ERMS and IRMS. This is x-axis, and here this one I call it ERMS. And we know that what is this phi? Phi is what we have taken. We actually today we are discussing about power. So what we considered earlier, we considered it that E is equal to, we have taken the EMF, E is equal to E naught sin omega t. E is equal to E naught sin omega t, and I is equal to I naught sin omega t minus phi. Minus phi means I current is phi angle behind E. Phi angle behind B. It is lagging behind E by phase angle phi. So that's why I have drawn ERMS here, and I will draw IRMS here. And as I mentioned, as I told you, that current is phi angle behind EMF. So I will take this angle to be phi. Is that clear to you? Is this clear?
Yes, sir.
Okay. Now, if I want to resolve the components of I, then I is making this IRMS, because I am talking about current, wattless current. So I am going to resolve the components of I. So along E, it will be I RMS cos phi. The along component is always, look, if I have this is x-axis, and if I have this A vector, if I have this vector A, and this is making angle theta here, so how to resolve the components? This A vector along x-axis, this is making A cos theta. A cos theta is the horizontal component, and if I take perpendicular to A cos theta, perpendicular to A cos theta is A sin theta. Perpendicular to A cos theta is A sin theta. So in the same way, this is IRMS, and along component is IRMS cos phi, and if I take perpendicular to IRMS cos phi, it will be like this. This angle is 90 degree. This angle is 90 degree. So this is IRMS sin phi. This is IRMS sin phi. So, is this diagram clear to you?
Yes.
Okay. So A part is this. The current IRMS can be resolved into two components. Component IRMS cos phi along ERMS as the phase angle between IRMS cos phi and ERMS is 0. Therefore, P average is equal to, now if I take the, if I have taken two different components of current here, because I have resolved this IRMS into two components. So one component is this one, IRMS cos phi, this one, and one component is this one, IRMS sin phi. So what is the angle between ERMS and this IRMS cos phi? The angle between ERMS and IRMS cos phi is 0, because they both are in same phase with each other. They both are along the same line. So angle between ERMS and IRMS cos phi is 0 degree. Therefore, power due to IRMS cos phi is P average is equal to ERMS into IRMS cos phi into cos 0. I hope that you are understanding. This time I am not saying that. I am going to take ERMS current, EMF as ERMS and current as IRMS, and angle between both of them as phi. This time I am saying that EMF is ERMS, and current is this complete component, this complete portion. IRMS cos phi is current. So this one is EMF, this one is current, and what is the angle between ERMS and IRMS cos phi? It is 0. That's why I have taken cos 0 here. So cos 0 is 1. So P average is equal to ERMS into IRMS into cos phi. All right. Now B part, angle between ERMS, angle between ERMS and IRMS sin phi is 90 degree. Angle between ERMS and IRMS sin phi is 90 degree. Therefore, P average is equal to ERMS into, this is ERMS and into IRMS sin phi, IRMS sin phi. And now what is the angle between this EMF and this current? What is the angle between this EMF and this current? It is 90 degree. Cos pi by 2. And what cos pi by 2 is equal to? Cos pi by 2 is equal to 0, and 0 into anything is equal to 0. So the average power in this case is equal to 0. And therefore this component IRMS sin phi, this is called wattless current, because this current is not producing any power. That's why it is powerless. Powerless means wattless current. We call the component IRMS sin phi as the idle or wattless current, because it does not consume any power in an AC circuit. Is this clear?
Yes.
Okay. Now on page number now this complete RLC series circuit and power of an AC circuit, everything is finished now. Now the numerical on page number 30, question number 1. A light bulb is rated at 100 watt for a 220 volt supply. So I am on question number 1. I am doing numerical first numerical on page number 30. Have you noted down till here?
Yeah, yes, sir.
So the component IRMS sin phi is called wattless current. Is called wattless current. Now, question number 1. A light bulb is rated at 100 watt for a 220 volt supply. Find A, first part hai, the resistance of the bulb, and B, the peak voltage of the source, and C, the RMS current through the bulb. So I have told you also that in case of the numericals of AC, the value of voltage which is given in the numerical is always ERMS. So a light bulb is rated at 100 watt. Light bulb is rated at 100 watt. It means that P average is equal to 100 watt. For a 220 volt supply, 220 volt supply means ERMS is equal to 220 volt. Find the resistance of the bulb. First of all, they are asking about the resistance of the bulb. We know that what is this resistance? What is this resistance? What is this bulb? In bulb, we know that bulb have only a small tungsten filament. It has only a small little wire, and that is only a resistance. So they are asking about resistance. So it is not an inductance. It is not an capacitance. It is a simple resistance. So we know that a bulb has only resistance. In bracket we will write no L or C. There will not be any L or C. So average power is equal to, I can write it like this, E RMS square upon R. This is P is equal to V square upon R. We have four formulae for calculating power in DC. Work done upon time taken. What is this work done? This work done is actually voltage is defined as work done per unit charge. So what is this work done? This is V into Q. V into Q, and this is time, and we know that Q upon T is called I. Q upon T is called I. That's why I can write it like this: V into I. P is equal to V into I. And what is V? V is equal to IR. So I can write it like this, like this. P is equal to IR into I, means P is equal to I square R. In the same way, I is equal to V upon R. I is equal to V upon R. So P is equal to VI, means P is equal to V, we write it simply V, and in place of I can write V upon R. So P is equal to V square upon R. So we have four formulae of power. One is work done upon time taken. Second is P is equal to VI. Third is P is equal to I square R. And fourth is P is equal to V square upon R. So in this question, we are provided with ERMS. ERMS is simply voltage. So ERMS, power, and they are asking about resistance. So I will write ERMS square upon R. Therefore, R will come here and P average will come here. R is equal to E RMS square upon P average. What is this E RMS? It is 220. 220 square upon 100. 220 multiplied by 220 upon 100. This 0 will cut this 0. This 0 will cut this 0. 22 into 22 is 484 ohms. Resistance is 484 ohms. Now, B part of this question. Shall I remove this or do you want to write it?
Oh, no, I'm done writing.
Okay. Okay. So, B part of this question. B part. They are asking the peak voltage of the source. Peak voltage. What is this peak voltage? This is E naught. ERMS is equal to E naught upon root 2. So what is E naught? It is ERMS multiplied by root 2. ERMS multiplied by root 2. What is ERMS? ERMS is 220 volt. And what is the value of root 2? It is 1.414. So if I remove the decimal from here, I will get 1000. All right. Multiply 22 by 1414. 22 fours are 88, 8 carry. 22 ones are 22 and 8 is 30. 3 is carry. 22 fours are 88 and 3 91. 9 is carry. 22 ones are 22 and 9 is 31. is 31, and 100 is there. So if I cancel out these two zeros, decimal will come here, 311.08 volts. This is E naught, 311.08 volts. Now C part, the RMS current through the bulb. RMS current through the bulb. They are asking IRMS. So P average is equal to ERMS into IRMS, as it is a purely resistive circuit case. So I will write simply, there is not any phase angle, so I'm not writing cos phi here. So P average is equal to the IRMS into IRMS. It implies that IRMS is equal to P average upon E. What is P average? P average is 100. And what is ERMS? It is 220. Cancel out 0 by 0, and 2 5s are 10, and 2 11s are this. So if I divide 5 by 11, 11 zeros are 0, 50 after decimal, 11 fours are 44, 50 minus 44 is 6, 6 0 60, 11 fives are 55, 5 like this. It will come, it will go on, 0.45 ampere. This is RMS value of current. Is this clear? Is it clear?
Yes, yeah, it's clear.
Okay. Anusha, we have 4 more questions. We have total 5 questions. So I am leaving these 4 questions for you, and I want you to do these questions and send the photographs of these questions to me. Send the photograph of the solution. Okay. And if you face any problem, then also I want to see that have you tried it or not. Send me that send me the complete photograph of the question which you have tried, and if you face any problem we will do it tomorrow in the class. Okay.
I'm not going to school tomorrow, so I'm really tired.
Okay, you will not be able to do it by tomorrow.
No, I'm saying that I don't have school tomorrow, so you can take class whenever you want.
Okay, this is
I'm just saying that I can't do it.
okay. And what happened yesterday, Anusha? I called you.
Yes, I wasn't here well, and then I don't have WhatsApp like, on my phone, right? So I slept off.
Okay.
Because then I woke up really early to church and stuff. But you can take like extra classes tomorrow for like as long as you need.
Okay, Anusha. Okay, if I get time, I will take your class in the first half tomorrow, and I will inform you about this. Okay. Okay, Anusha. Good night.
Mm,
Okay.
so,
Bye.